Hello viewers, welcome to the session on evaluation techniques for regression models in machine learning. Please make sure to watch all the prerequisite videos for your clear understanding and to make best use of it. Firstly, let's understand what is root mean square error. So, it is defined by the formula 1 by n summation of yi minus yi cap whole square, where yi is nothing but our actual value and yi cap is the predicted value, and we have to do the square of this difference. So the difference of actual and predicted value and square of it and the mean of this whole. So you can state it as the mean of square of actual and predicted value of a given data set is known as root mean square. So let's understand it numerically with an example. Let us suppose this is our actual data set, where on the basis of the height we have given that these are their weight, and we are given a regression line where it is defined as y is equal to 9.2 plus 0.8x. By substituting the value of x in this regression line, we get these estimated values, and we have to find the error. So the difference between yi minus yi cap. So it has been calculated here, and we have to do the square of it. So here we are having the error squared, and after that we have to do summation of all these errors squared. So I have done the summation of this square, and then we have to take the mean of this square. So since we are having 5 observations, so 30.4 divided by 5, we got the root mean square as 6.08. So this is nothing but root mean square. Now let's understand what is root mean absolute error. After understanding root mean square, this is going to be cakewalk for you. So it is defined by the formula 1 by n summation of absolute value of yi minus yi cap. So here yi is nothing but your actual data and yi cap is your predicted value. So the absolute value of difference between actual and predicted value and its mean is known as root mean absolute error. And let's take the same example, and let's suppose that this is the height of children and the weight corresponding to the height, and these are the estimated. Then the difference are this, and the absolute error is nothing but the modulus of this value. So it has been there, and we have to do summation of the same. So it has been calculated, and then we are calculating the mean. So this is the root mean absolute error. So the one thing in mind that you need to keep in your mind is that the very important thing that you need to keep in your mind is that the root mean square error and root mean absolute error, the least it is, the best is our prediction. Okay. Now let's move into the R square. Very interesting concept, where finding the R square is given by this formula 1 minus summation of yi minus y cap whole square whole divided by summation of yi minus y bar whole square. So here yi is nothing but our actual data, and yi cap is nothing but our predicted value, and y cap is nothing but the mean of the actual data. And moreover, whenever the R square is, the value of R square lies between 0 to 1. So whenever the R square is 1, then all our predicted values are in line with the actual value. And you can see the same in this graph also. Similarly, if our R square is 0.83, which means 83% of our predicted value are in line with the actual value. You can see here. So the R square should be near to 1 for our best prediction. And whenever R square is 0, which means it is the worst model prediction. Okay. Now let's understand it through an example. Let us suppose we are given a regression line, and we have plotted the regression line as this. And we are going to calculate these are the actual values, and we are going to do the predicted values, and then we are going to calculate the R square step by step. Firstly, for 2 by 2, we have calculated the y cap as from the regression line. We are substituting the x value as 2. We have got it as 2.01. But the actual value for the x is 2. So we have calculated the residual 2 minus 2.601, which has come out to be negative 0.601. Similarly, it has been calculated for the points 3, 4, where the actual value is 4, but we have got the predicted value through the regression line as 3.83. So we have calculated the error similarly for the 4 by 6 point and also for the 6 by 7 point. And for calculating R square, we need the summation of yi minus yi cap whole square. So we have to square each of those terms, and we have added and we have got the value as 1.542871. So next step is that we need a mean of the actual data. So for mean, we have calculated a mean 2 plus 4 plus 6 plus 7 whole divided by number of observation by 4, and we have got the mean as 4.75. So now we can calculate summation of yi minus y bar whole square. So the same has been calculated, just we are substituting the required values and we have got the value as 14.75, and then we can calculate the R square, which is defined as sum square regression 1 minus sum square regression by total sum of squares. So we are just substituting the values and we have got it as 0.895. So this is the actual value, actual predicted score. 89% of the predicted values lies in line with the actual value. So once knowing the R square, now let's jump into adjacent R square. So this is just icing on the cake after understanding the R square, as adjusted R square is calculated with the same R square value what we have calculated earlier, but the only difference here is that we take in account the total number of samples and the number of independent variables here. So adjusted R square is more better than R square. However, the theme behind them, both of them are same. And now adjusted R square is calculated here. 1 minus R square value has been calculated as shown in the previous slide. And after that, total number of sample size. There were 4 records, so we have taken the 4 points. So we have given the value of n as 4. And also the number of independent variables. We were having just one independent variable there, so we have written as 1. We have taken p as 1. And then we have just done the calculation. I have got the adjusted R square as 0.8425. Now hopefully you have enjoyed all the numerical examples of the evaluation metrics of regression models. Now it's time for your favorite hands-on session on regression evaluations in Python. So for evaluating our regression model, I am evaluating for the linear regression, simple linear regression that we have already solved in the previous videos. So after solving this, I want you to try all these metrics on the all other regression types. So I'm just using it in the simple linear regression, and I wish you to try on all the different other than the simple linear regression, such as polynomial regression, support vector regression, decision tree. Try this and you will get an edge over the topic. So for calculating the mean absolute error, from sklearn we have sklearn library, we have metrics module in which we have mean absolute error class. So I am storing the mean absolute error in the object A1, where I am passing the y test and y predicted value. So, and I am printing the mean absolute error. Let me execute the same. See, the mean absolute error has been calculated as 3737. Okay. Similarly, for calculating the mean square error, from sklearn library we have metrics module in which we have mean square error class, and we have to pass all these tested and predicted values. You can also see the documentation here. Just a second. By the time it gets loaded, yeah, see here. You can see the mean square error is taking the parameters as the true values of the target variable and the predicted value. So we are passing the same here. And now let me execute this chunk of code and let me print the mean square error. So the mean square error for our prediction has been calculated here. Similarly, now let me explain the variance score. For using the explain variance score, from sklearn library we have metrics module in which we are having explain variance score, where it is going to give us the explain variance score. the variance of the model can be predicted here. Say it has been come out to be 97%. Similarly, in order to view the R square and adjusted R square for our prediction model, we have ordinary least square class. My bad, SUUAR. Yeah, now it's correct. Okay, for using the ordinary least square class, we have to import stats model.api, and I have given the alias as sm, and I am using a object model where I am fitting this independent and dependent variables. See, it has been fitted successfully, and after that, let me execute this chunk of code so that you can understand it clearly. So it has been executed successfully, and now I want to print the summary of model summary so that we can view the R square and adjacent R square. Now the R square and adjusted R square for the linear model has been calculated here, and you can view the same. I hope this video proved fruitful to you, and hope you have gained something extra than what you were knowing earlier. Thank you.